This is lesson 5-7, make and test conjectures. Our essential question, how do you make and test a conjecture? We have one vocab word, conjecture, which is a generalization that you think is true. So I want to kind of make a connection here to something we talk about in science a lot, which is hypothesis. Because a conjecture is very similar to a hypothesis. So we're kind of making an educated guess. So we're making a guess based on facts that we have, based on something we think is true. So example number 1, we're going to explain whether this conjecture is correct or incorrect. So the difference, and you're going to have to kind of break apart these sentences so make sure you understand what they're asking. When I say the word difference, I know that means subtraction. So I'm looking at something that is going to be working with subtraction. So the difference of two odd numbers is always even. So when I subtract two odd numbers, I should get an even answer. And the way we're going to figure this out is to simply do some examples. So let's subtract two odd numbers and see if we get an even number. So let's do we're going to do 9 minus 7. And if I have 9 and I take away 7, my answer is going to be 2. And 2 is an even number. So that means that would be true. The difference of two odd numbers is even. So let's try another example. We're going to do 7 minus 3. And 7 minus 3 is 4. And 4 is an even number. So yes, that would be true. And let's do one more just to make sure. We'll do 5 minus 3. And 5 minus 3 is 2. 2 is an even number. So based on what we've done, based on our testing of this conjecture, we can say that it is correct. And it is correct because when we did 3 examples of subtracting two odd numbers, we got even numbers as our answer. All right, example number 2, we're going to test this one out and see if it's correct or not. So the sum, and sum is when I am adding. That's my answer to an addition problem. So the sum of two decimals is always a decimal. So when I'm adding two decimals, I should always get a decimal answer. And always is the key word there. They're not saying sometimes you get a decimal. They're saying every single time you should get a decimal. So let's try it out. Let's pick two decimals. We'll have 5/10 plus, and I'm adding because it says sum, plus 2/10. Remember, you bring that decimal straight down and you add like normal. So I got 7/10. So that would mean that, yeah, that's true. My answer is a decimal. Let's try another. 12 hundredths plus 31 hundredths. And we bring that decimal down and we add like normal. And again, my answer is a decimal, so yes, that would make it true. And let's do one more just to be sure. If we have 8/10 plus 2/10, and we bring that decimal down and we add like normal, we would get 1 0/10. Now if I just have a 0 over here in my decimal and I have no other numbers, that has no value at all. So really, my answer is just 1. And 1 is a whole number. So we just proved this to be incorrect. Because when we added 8/10 and 2/10, we got 1 whole. So this is incorrect. And we would use this problem as our explanation. Our last example, we're explaining again if it's true or not. So composite numbers, remember composite numbers have more than 2 factors. So we're saying composite numbers have an even number of factors. So if I list out all the factors, it should be even. So let's pick a composite number. Let's start with the number 12. And let's go ahead and list those factors. 1 and 12, 2 and 6, and 3 and 4. And let's count up how many factors it has. It has 1, 2, 3, 4, 5, 6 factors. And 6 is an even number. So that would prove it to be true. And let's try another one. Let's try 20. So we have 1 and 20, 2 and 10, and 4 and 5. And again, that has 1, 2, 3, 4, 5, 6 factors. 6 is an even number. And we're going to do one more. Let's do the number 4. 4 has 1 and 4, and 2, and 2. Now this one's a little tricky. It has 1, 2, 3, because we can't count the number 2 twice. It's the same number, so we can't count it twice. So this one doesn't count. So it only has 3 factors. And 3 is not an even number. So this just proved this conjecture incorrect. And we would use this problem as our explanation. You have 2 conjectures that you're going to prove them to be correct or incorrect. There shouldn't be as either. That's a typo. So number 1 says all multiples of 6 end in 0, 2, 4, 6, or 8. Remember, multiples are skip counting. So if you were skip counting by 6's, all of your numbers should end in 0, 2, 4, 6, or 8. And then number 2, a greatest common factor cannot always be found for 2 whole numbers. So you're going to have to pick 2 whole numbers and see if you can find greatest common factor for them. And then explain why it is correct or incorrect. Don't forget a word problem or rate your understanding, word problem or question, and then rate your understanding.